This lesson is going to be on some coordinate geometry. We're going to talk about the coordinate plane and a lot of its vocabulary. So the coordinate plane is what we call our graphing surface. So this grid is what we're looking at. So the first thing we have is what's called the x-axis. The x-axis is this line that goes from left to right. So this little dark black line from left to right is what's called the x-axis. The y-axis, let's see, it's got this y up here, this vertical line right here is the y-axis. So this dark line that goes up and down, this vertical line is what's called the y-axis. The origin is a special point. So right here at 0, this spot on the graph, that's described as the origin. That spot right there, that's the origin. Now, when you look at the graph, notice that the horizontal line, the x-axis, and the vertical line, the y-axis, it divides the piece of graph paper, if you will, the grid. It breaks into 4 regions. Quadrant 1 is this upper right-hand area. So quadrant 1 is this region over here, the right and up region. So if you go right and up, this space here is called the quadrant 1. So quadrant 2, we kind of go counterclockwise. So quadrant 2 would be this region over here. So quadrant 2 is when you go from 0, if you go left and you go up. In other words, if you go in a negative direction and then a positive direction, you're in what we call quadrant 2. So if you go right and up, so if you go positive and a positive, that's going to put you in quadrant 1. And in quadrant 2, if you go left and then up, in other words, if you go in a negative direction and then in a positive direction, that puts you in a second quadrant. The third quadrant is this bottom left area. So if you go negative and then negative again, that's considered quadrant 3. So quadrant 3 is when you go negative and then you go negative again. So that's quadrant 3. Quadrant 4 is when you go to the right and then you go down. So if you go in a positive direction and then you go in a negative direction, that's described as the 4th quadrant. So those are some key vocabulary things. The x-axis, the y-axis, the origin, and then these 4 regions or quadrants. Quadrant 1 is the top right. Quadrant 2 is the top left. Quadrant 3 is the bottom left. And quadrant 4 is the bottom right. So the next thing we want to talk about is what's referred to as ordered pairs. Ordered pairs are used to locate a point on the graph. So a specific spot on the graph we call a point. Ordered pairs are in the form of what's called the x-coordinate and the y-coordinate. So x goes first, y goes second. So the first number describes how you move in a left to right direction because the x is moving left to right, depending if you're positive or negative. The y-coordinate is going to dictate how you move up or down because the y direction is a vertical direction or up and down. So if I want to plot point A, this 4, 6, what you do is you start at the origin and then you go to the right 4, 1, 2, 3, 4, and then you move up 6. So from there you move up to 6 and you would make your little point. So that point is the location of point A. Point B would be 6, 1. So 6, 1 means you go to the right. From the origin, you go right 6. And then the 1 tells you to move up 1. And then once you move both of those directions, you're now at that location. So that would be what's described as point B. 5, 0 means, again, you're starting at the origin. The 5 means you would move to the right 5. 0 means you don't move up or down, so you just stay right where you are. So you're still on what's called the x-axis. So point A is on quadrant 1, Point B is in quadrant 1. Point C is actually on the x-axis. Point D is -1, 5. So from the origin, the -1 now means you move to the left, and then you have to move up 5. So you make a little point right there. That would be the location of point D. So point E would be -5, 3. So from the origin, if you go left 5, 1, 2, 3, 4, 5. Notice how you have these markings here to help you understand where you are. So -5, and then you go up 3, 1, 2, 3. You would be at this spot right here, and that would be point E. Point F would be 0, -4. So 0, -4 would actually put you don't go left or right, you would just go down 1, 2, 3, 4. So point F would be at 0, -4. That would be on what's called the y-axis. Point H, -2, -3. -2 would move you left 2, and then you move down 3, 1, 2, 3. You'd be located at this spot right here. That's going to be point H. Let's see. And then point I would be -6, -4. So I go left 6 and then down 4. 1, 2, 3, 4. So notice I'm kind of looking at the numbers. That should be up there. There we go. Didn't count that right. So 1, 2, 3, 4. That would be point I. I would be located here. Point J would be 0, -5. So 0, -5, again, you don't move left or right, you would just move down 5. So you'd be moving in what's called the negative direction. And that would be point J. And then 2, -3, right 2, down 3, that's going to be point K. And then 5, -5, 1, 2, 3, 4, 5, gets me over here. See, there's that number. And then down 5, -5, so you locate that, and then you make your little point. And that's the location of point L. So L will be located there. So that's how you'd be graphing some of the coordinates. So where the coordinate plane for us is going to focus on, it's going to be more about what we call a two-variable equation. This is sometimes called a function. A two-variable equation, again, it's most commonly called a function, usually involves x and y. So when I define the function, typically you're going to see x and y. It doesn't have to be x and y, but that's just the more common letters you see, the two variables. The x will stand for what we refer to as the input, and the y will stand for the word output. So you have this input-output concept. So the equation is most useful if you actually have the y on one side by itself. So this allows us to use what we refer to as an input-output table. And to solve for y in a two-variable equation, again, you want to use the zero pair to remove the addition part, and you want to use division to make the coefficient equal to 1. So if I look at this equation, I have -4x plus 7y equals 2y minus 3. Again, remember that's like a plus -3. So if you need to do that, you can. And again, I want to get y by itself. So the addition part, I want to zero it out. So since that's a -3, we want to add a +3 here. But we want to add a +3 over here. And since it's a like term with the 7, we put those together. So I have a -4x. And then 7 plus 3 is going to be 10. And then you have 2y. The -3 plus the 3 is going to just zero out, so we can drop that out of the problem. And then to make the coefficient turn into 1, we want to divide each side by 2. So the trick here is I got to divide the whole side by a 2. So 2 would go into a 4 twice. It's going to stay negative. So it's going to be a negative 2x. And 2 would go into 10 5 times. So I have to divide both of those terms by the 2. So I end up with negative 2x plus 5. And then that's just going to equal y. And most commonly, it's written the other direction. It's written as y equals negative 2x plus 5. But they're both correct. It's okay to switch the sides around. It doesn't change anything. It's still a true statement. So when I see this 3x plus y equals negative 12, the key is to get the y by itself. So the 3x has got to go away. So its zero pair would be, I would want to add a negative 3x here, as long as I add a negative 3x to the other side of the equation to keep it balanced. So the 3x to negative 3x will zero out, and that just leaves you your y. But negative 3x and 12 are not like terms, so I just bring them both down. They can't be added together. So this is the negative 3x plus the 12, since they're not like terms. And typically we write the x first and then what's called that constant second. So again, I see subtraction, so I want to make that plus a negative 2y. Kind of use that KCC method. And again, to make the 6 go away, because I'm trying to get the y by itself, I want to get rid of the adding part first. So to make the 6x go away, I want to use its zero pair, which is negative 6x. But also got to add that to the other side of the equation, so I'll put a negative 6x over here as well. So that's going to give me this negative 2y. And that's going to equal then negative 6x plus 8. And then to make the coefficient turn into 1, I have to divide by the coefficient, so I have to divide by negative 2, as long as I divide the other side by negative 2 as well. So the negatives will divide out over here, so that gives me a y equals. And then negative 2 goes into negative 6 3 times, and we know that a negative divided by negative is a positive, so it's going to just be 3x. And then negative 2 goes in 8 4 times, so it's going to be plus a negative 4 or minus 4, whichever way you like to write that. Most commonly, you'll see it written as 3x minus 4, because they mean the same thing. It's just less writing, one less symbol to put on paper. So again, this still reads though as y equals 3x and a negative 4. Remember, these are terms. The first term is a 3x, and the second term is a negative 4. So I still kind of read it as an addition problem, and that's kind of the trick of all this. So the next thing we want to do is we want to make this input-output table. So a table, again, is just that T-chart. And to make 3 solutions, what we do is we pick our own input. So I'm going to just use 0 as a starting point, because 0 is usually a pretty easy number to do. And what I do is I replace, so this is going to be my input, which is x, and my y is going to be my output. So the left side is your input, your right side is your output. So I use the letter x for input and the letter y for output, just saves writing. So what this tells us to do is I have to substitute the 0 in for x. So this becomes then y equals 2 times 0. And then that's going to be plus a negative 5. And then, well, 2 times 0 is going to be 0. And 0 plus negative 5, this is going to be negative 5. So when x goes into the rule, the function, the result is the output is going to be a negative 5. This also forms what we call an ordered pair. So the x is going to be 0, the y is going to be a negative 5. So that creates what we refer to as that ordered pair in the table. So to keep the math easy, I'm just going to choose 1 as my next number. So that's going to be y equals 2 times 1. And then let's just say minus 5, you're going to be adding a negative 5 to that. Again, that's that KCC thing. Change it, change it. So 2 times 1 is 2, and 2 plus -5, that's going to give me a -3. So the solution for the y is a -3. And that creates the order pair 1, -3. And then to keep it easy, I can put the 2 in. So I'm just going to keep it easy on my input values 0, 1, 2. And that's most common what I do is just 0, 1, 2 because it makes the math easier. So 2 has to go in for the x, so that gives me y equals 2 times 2, which of course is 4, plus a -5. 4 plus -5 would be then a -1. So some of the math you can start doing in your head as you get stronger with your math reasoning. So that order pair would be then a 2, -1. And you know what we would do with order pairs would be probably graph them sometime, but right now we're not asked to do that. So if I make a table for this one, so my input output table, so XY chart as well. Again, I like to choose 0, 1, 2 if nothing looks fishy. So that's going to be y equals -4 times 0 is still going to just be 0. And 0 plus 3 is going to be 3. So I'm just going to do that multiplication in my head to keep it a little bit cleaner on my paper. So 3 would be my y value. So therefore my ordered pair would be 0, 3. So when x is 1, that's going to be y equals, and then -4 times 1 is just going to be -4 plus 3. And then using your label thinking, there's more debt, so I'm going to have $1 of debt left. So 1, -1 would be that solution, input, output, which makes the order pair 1, -1. And then when 2 goes in, so -4 times 2 would be -8. -8 plus 3. -8 plus 3 is going to be then -5. So that's going to give me a -5. So that order pair would be then 2, -5. And then this last one here, y equals -3x plus 2. Again, I'm going to make a table. Again, I like to just use 0, 1, 2 whenever possible. And that's not always going to be true, but in these, the whole number math or the integer math looks pretty easy. So when I do the math here, you know, y is going to equal -3 times 0, which is 0. And that's just going to be a -2 there. So I can just put plus -2 to make it easier for me to see it. And that just becomes then -2. So 0, -2 would be a solution. So 0, -2 would be the ordered pair. If I put a 1 in, -3 times 1 is still going to just be -3 plus -2. So it's just going to be a -5. So 1, -5 would be my input output table, which creates the order pair 1, -5. Put a 2 in, -3 times 2 is going to be -6. And then you also have a -2 there, which would in turn be a -8. So 2, -8 would be that input output table values. And then as an ordered pair, you would have 2, -8. So for function, sometimes instead of y, they'll use f of x or g of x instead of using the y variable. And this is called a function notation. So you may see f of x, g of x. So on testing, you know, I may be given this function f of x equals 3x plus 2. And they may ask us to find f of -5. So notice how that's really where x is. So the -5 represents your input value. So to find -5, we're just basically looking for that output value. So it's really the same math as what we were doing. The -5 goes in for x, and then you just got to add a 2. So 3 times -5 would be -15. -15 plus 2 would be then -13. So f of -5 would be -13. G of x may equal -4x plus 3. They asked us to find g of -2. So g of -2 just means to substitute the -2 in because it's our input value. So that's going to be -4 times -2 because you're going to replace x with -2. And again, notice I like to use parentheses when I substitute in like that. And then you have to add 3 to that. Well, we know that 4 times 2 is 8, and we know that a negative times a negative, that's that light switch, that becomes a positive 8. 8 plus 3 then turns into an 11. So g of -2 would be equal to 11. So graphing functions, or in particular, we're going to be graphing linear equations basically here. The graphs will all look like lines. So all graphs won't look like lines, but these equations actually do when they take on this look right here. So to graph a function, what we're going to do is make a table, and that's going to help us find the 3 solutions. We want to then identify the ordered pairs and plot points, and then we want to draw a line through the points. So we want to make a table. That's that input-output table. We want to identify those ordered pairs. We then want to plot those points. And then once you plot those points, you're going to draw a line through those points, and that's going to be the graph of this function. So when I do this math, again, I make my input-output table. Again, I like to use 0, 1, 2. It usually keeps math the easiest. So 2 times 0, and then I'm going to add a -3 to that because I don't want to see subtraction there. 2 times 0 is 0, and then plus a -3. That's going to give us then a -3. So 0, -3 would be that input-output table. So if I put 1 in, 2 times 1 plus a -3. So that's going to be 2 plus -3. That's going to give us, since the signs are different, we're going to subtract 3 minus 2 is 1. Keep the label of the bigger one. That's going to be then a -1. Or just, I have $2, but I owe $3. I should still be $1 in debt. And that should make the math make sense. So then I put 2 in. So 2 times 2 minus 3, or in other words, plus the -3. Well, 2 times 2 is going to be 4, and 4 plus -3 is going to give me a +1 because you now have more money than you owe. So when the signs are different, you're going to subtract again. 4 minus 3 is 1, but keep the label of the larger value, which is a positive. There's more money left. So then if I look at my ordered pairs, that's going to be a 0, -3. So I'm identifying my ordered pairs. 1, -1 is an ordered pair. So that's how we use a set of parentheses there to organize them, and also that comma comes in. So a 2, 1 also comes into play. So when I graph those, 0, -3, 0 means don't go left or right because that's your x direction. The second number is always your y direction, up and down, so I only go down 3 and I make a point. 1, -1 means starting at the origin, you go right 1 and down 1. So 1, -1 will be located there. And 2, 1. So right 2 and up 1 would be located here. So those points should line up. So I then can kind of just try to freehand draw my line through here. Let's see if that's going to, wish I had a straight edge. I just don't have one right now. So we'll just have to rough it out a little bit. But that's what you come up with is what's called a line. And that's the graph of this function. It looks like that. So again, to graph this function, we're going to do the same thing. We're going to make a t-table. We're going to identify those ordered pairs. We're going to plot those points and draw a line. So again, I'm just going to use 0, 1, 2, since the coefficient's just a nice clean number. So 3 times 0 is 0, and 0 plus 1 is just 1. So I'm going to do some of the math in my head to keep it a little bit easier and cleaner on the paper. 3 times 1 is 3, plus 1 more is 4. Actually, I can just do that all together, really. 3 plus 1 is 4. That math is very easy to do. So 3 times 2 would be 6. 6 plus 1 would be 7. So I would have 1 here, 4 there, and 7 there. So your order pairs would be 0, 1, 1, 4, and 2, 7. So 0, 1 would be here. 1, 4 would be here. And 2, 7 would be here. So we want to line up those points and draw the line through those. So I'll try to do this with my mouse. Not very easily done. We'll see how much my hand shakes. There's supposed to be a straight line. So one of the things that's kind of cool is where it crosses the y-axis is a very special point. That's referred to as the y-intercept. That's where it crosses the y-axis. So there's a nice little word that we may come across on the GD test is y-intercept. That's where the graph crosses the y-axis. It's usually the first point we find because it's when x is 0. So when x is 0, you're always going to be finding the y-intercept. So it's typically, if I'm making my table, it's typically the first solution that I find because that's when x is 0. So that would be the graph of that function. So to graph a function, again, we're going to make a table by finding 3 solutions. We're going to identify the ordered pairs. We're going to plot those points, and we're going to draw a line through those points. So I have y equals 1/2 x plus 1. So I'm going to have my input-output table. X goes first, y goes second. So I'm going to start with x equals 0. So I have 1/2 times 0 plus 1. Again, 1/2 times 0 is still going to be 0, and 0 plus 1 is just going to be 1. So 1/2 basically means you're going to divide by 2. Well, 1 divided by 2 is not very pretty. So what I want to pick up on is, this is kind of fraction stuff. So this really means you're dividing by 2. The only numbers that really can be divided by 2 are even numbers. So the next number I'm actually going to choose is 2 and 4, because only even numbers can be divided by 2, because that's what half kind of means. This is in a, remember how you have that fraction bar, divide by 2. So when I put the 2 in, that's going to be basically 1/2 times 2. And then you're going to add a 1 to that. So again, 2 goes into 2 one time, so that just divides out. And 1 times 1 would just be 1. Of course, we knew that half of 2 is 1. So that just turns into 1 plus 1, which is going to still be, let me see, don't need an equal sign there. That looks confusing. So we end up with a 2. So when I put a 2 in, I get a 2 out. So putting a 4 in, so that means 1/2 times 4 plus 1. So again, what the fraction bar means is divide by 2 and then turn around and multiply by 1. That's the easiest way to do fractions. So 2 goes into 4 twice. So I do that math and just write down that. And then 2 times 1 is 2. And you may already know half of 4 is 2. that's what it looks like as well, is you just divide the 2 into the 4, then you multiply by the 1. That gives me then 2 plus 1, which in turn gives me then, this is going to be a 3. So my ordered pairs would be then 0, 1, 2, 2, and 4, 3. So then I would want to graph those solutions. So 0, 1 would be, don't go left or right, just move up. 2, 2, right 2, up 2 would be here. And 4, 3 would be right 4, then up 3. So those points look like they line up. Now the job is just draw a line through those, and I'm going to kind of work my way a little bit further over to see if I can get this angle down. Missed him, got him, and then, so line just keeps on going forever. Sometimes you may have to make the dot a little bit bigger so they touch a little bit. So that would be the graph of that function. So we want to graph this function as well. Again, we want to make a table. We want to identify the ordered pairs. And then we want to plot those points and draw a line through those points. So again, I'm going to have my input, output. And notice how, again, we have a fraction as a coefficient. 0 is always a good number, so we can never go wrong with 0. Negative 2/3 times 0 is just going to be 0. That was pretty easy. Now, what dictates this next number is, since you're dividing by 3, we want to pick multiples of 3. So 3 times 1 is 3, so we want to pick that one. And 1 multiple of 3 would be like 6. So we could probably choose those values. So that means negative 2/3 times 3. I don't know what's going on there. We'll just have to ignore that. So remember, this means division of 3. So I'm going to divide the 3 into the 3 to start with. Makes the math easier. Do the division first. So 3 goes into 3 one time. And then 1 times negative 2 would be then negative 2. So when 3 goes in, negative 2 comes out, input, output. The x value is 3. The y value is negative 2. And then if I put a negative 6 in, negative 2/3 times 6. Again, we start with the division first because it makes the math easier to do. So 3 goes into 6 twice, and then 2 times negative 2 would be negative 4 using our light switch thinking. So when I graph it 0, 0 is my first point. It's 3, negative 2, so it's right 3, down 2, that would be here. And then 6, negative 4, 6, and down negative 4. So that would be where I've got it. And see if I can draw this any better. Not bad. So there would be the graph of my line. Notice this time it crosses the y-axis at 0, or the origin. So again, at the origin, that would be where we would describe that as the y-intercept. The y-intercept is equal to 0. That's the origin. So let's move on. So to graph this one, we have y equals 3x. I'm sorry, y equals 3. There is no x. So to make this easy on ourselves, what I can do is say y equals, and just say, because I need a place to put my input. So what I discovered is the coefficient of x is actually a 0, because that makes the x drop out of the problem altogether. So if we need to, we can write the equation as y equals 0x plus 3. That kind of helps you identify where the input's got to go. So again, no fractions involved, so we can just keep it with our simple ones, 0, 1, 2. It's only when fractions are involved that we have to get creative with our input values to make the math work out easier for us. So 0 goes in, so 0 times 0 is 0, and then 0 plus 3 is 3, so I can just do that math in my head. 1 goes in, 0 times 1 is 0, plus 3 is 3, so the y value again is 3. 2 goes in, 0 times 2 is 0, and 0 plus 3 is 3, so the y value doesn't change. That's why sometimes we use that word constant. So our ordered pairs will be 0, 3, And then we have 1, 3. And we have 2, 3. So 0, 3 would be 0, 3 would be, don't go left or right, just go up 3. 1, 3 means go right 1, up 3. And 2, 3, 2, 3. So this is what looks like a horizontal line. Graph looks something like that. Notice it says y equals 3. And notice that our y values are 3. So the input values can change, but the y value is locked in. It has to be 3. So this is a kind of a special function. So sometimes they're kind of strange looking, but they're actually very easy to do if you are just paying attention to the rules.